Welcome, everyone. Thanks for joining us today. Our presentation today is Efficiency Opportunities of a Comprehensive Water Management Program. And just so you know who you are listening to today, here is my bio. My first career was in facilities and construction management for the Navy, including 2 tours as public works officer, one at Naval Station Rota, Spain, and the other at the Naval Academy in Annapolis, Maryland. My second career has been with Phygenics, helping facility owners manage their building water systems safely and cost efficiently, with an emphasis on higher education facilities and VA hospitals. I currently live in Virginia Beach, Virginia, but I travel the country working with clients and our field personnel. And just so you know who Phygenics is, our core purpose is to help facility managers optimize the total cost of their water systems by improving safety and efficiency. Building and operating comprehensive water management programs is all we do, all day, every day. We like to start all of our presentations by explaining our bias. Although many of us don't think about it, every speaker or presentation has a bias of some sort. We like to put ours on the table so that you can judge and evaluate where we are coming from. Phygenics chooses to be independent from profiting on the sale of water treatment products and services. Our only bias is to work with facility owners and managers to achieve defensible, data-driven, comprehensive water management programs which verify and validate that their building water systems are safe, efficient, and cost-effective. Here's our agenda. First, some background on water safety and efficiency guidance and challenges. Then I will explain what a comprehensive water management program is. And next I will cover ways to improve water safety and hopefully save money at the same time. And lastly, validation, verification, and documentation. Or said another way, how to run your comprehensive water management program and achieve your goals in an operational setting. Building water safety guidance. This is not an all-inclusive list, but it is some of the most important water safety references and guidance. ASHRAE Standard 188, Legionellosis Risk Management for Building Water Systems. Don't let the word Legionellosis in the title fool you. This standard is about controlling all the hazards in building water systems, biological, chemical, and physical. Follow this standard and your building water system will be in good shape. It is written in building code ready format. Parts and pieces of the standard have already been incorporated into building code in various states and cities, with more to follow. The CDC Toolkit is sort of a companion guide to implementing ASHRAE 188. The AWWA has a standard for disinfecting water mains, which is quite useful. Then there is the federal overarching law with the EPA Safe Drinking Water Act and the National Primary Drinking Water Standard. What you won't find in any of these documents is a discussion on water efficiency or cost savings. This is also not an all-inclusive list, but it is some of the references and guidance on water efficiency. High-performance green building design, the Green Construction Code, leadership in energy and environmental design, and the efficient use of water in building mechanical systems. And although there is much more awareness now in the design community of the nexus of water efficiency and water safety, you will find little to no discussion of water safety in these documents. So now that we have looked at both water safety and efficiency guidance, what are the challenges? The most common problem today is water quality degradation. In other words, water age. How long does your water sit in your pipes before it comes out of a fixture? What temperature is it at while it is sitting there? The disinfectants added to your water dissipate over time. The longer it sits, the more likely it is that there will be little to no disinfectant in your water when it comes down those last few feet of pipe and through your faucet or shower or drinking fountain or ice machine. Biological hazards include many waterborne pathogens, including Legionella. A chemical hazard is disinfection byproducts from chlorine or chloramines, as well as lead, copper, and other contaminants. And all the good-intentioned initiatives to use less water inadvertently created a whole range of other problems. New construction and renovation projects have very special challenges. And one of the most costly challenges, because of the amount of money spent on heating and cooling water, is the fouling, chemical or biological, of heat transfer surfaces. This fouling silently wastes energy. I call this getting mugged without knowing it. This is a model that represents how water is managed currently in most facilities. Versions of this model have been used by the Veterans Health Administration, for example, to illustrate the current situation in many of their facilities. The graphic represents a balance. The balance beam represents cost of operations. The facility management team is at the fulcrum with the burdens of using water efficiently on the left and using water safely on the right. As is shown graphically, this situation is inherently unstable. Facility managers cannot sacrifice safety for efficiency, nor can they effectively improve efficiency but sacrifice safety. A comprehensive water management program can help facility managers optimize cost while improving both safety and efficiency. Let's look at an example of what can go wrong if you do not balance the two. As most of you know, LEED, or Leadership in Energy and Environmental Design, is a green building certification program that recognizes best-in-class building strategies and practices. Water use efficiency efforts in this particular facility did conserve water. However, water quality in the building degraded as a result of these efficiency efforts. This degradation in water quality caused increased microbial hazards that caused disease and injury to building occupants. Water use efficiency efforts in this particular facility did conserve water. However, water quality in the building degraded as a result of these efficiency efforts. This degradation in water quality caused increased microbial hazards that caused disease and injury to building occupants. Therefore, the facility managers were forced to direct time and money in order to balance the increased burden of water safety. This graphic illustrates that the fulcrum moved to the right in order to balance a larger, heavier safety burden. The reaction was expensive and disrupting. If the facility management team did not react, then the consequences could be catastrophic to the organization because disease and injury to building occupants is tremendously damaging. This model illustrates that the current status quo for dealing with building water systems is too reactive. It is not proactive and it is not sustainable. In this case, the facility management team reacted with these actions. They flushed taps using additional water. They used bottled water for hand washing and drinking. They performed 2 hyperchlorinations as remediation. They installed a supplemental disinfection unit, and they banned employees from using showers. Reactions like this are disruptive and expensive. They can cause brand damage to the organization and lead occupants of the building to worry about all kinds of unrelated issues. Their efficiency gains were entirely offset by the costs necessary to deal with the health and safety associated with water in the building. Now let's look at a sustainability model for the efficient and safe use of water in buildings. What is a comprehensive water management program? It is a documented, ongoing program that, when implemented properly, optimizes the total cost of building water systems by improving safety, efficiency, and asset preservation. It includes all of the different potable and non-potable uses of water in a building. What makes a water management program comprehensive, defensible, and cost-effective? First, it improves human health and safety by achieving alignment with regulations and standards. It improves water and energy efficiency by achieving sustainability targets. It optimizes the lifespan of capital assets such as boilers, chillers, and cooling towers. It optimizes the cost to treat water. And it documents all of these activities. This graphic represents an interlocking system of potable and non-potable water, along with the safety and efficiency and cost aspects of operating your building water systems. You cannot manage one piece of the system without considering the impact to the rest of the puzzle. ASHRAE Standard 188 has a 7-step process for developing a safety water management program. We have modified it slightly to come up with a process for building and operating a comprehensive water management program. We're not going to go through the 7 steps with you today, as it is not pertinent to the focus of our discussion, and we just don't have enough time. In fact, we have an 8-hour ANSI certified course on CWMPs. But I will say that the most important step is step number 1. You need to form a team that has both the responsibility and authority to act. It needs to include all of the water stakeholders, not just the facility and utility departments. Be sure to include environmental, health, and safety, the housekeeping department, and other users of water in your facility. Jumping to step 4, analyzing water systems for safety and efficiency. This is the step where you uncover the opportunities, as we call them, to improve water safety and efficiency while reducing your cost. The focus of this brief is on efficiency and cost optimization, so I will just briefly touch on safety just for your awareness. First, hazard is not equal to risk. Risk is an evaluation of the hazard, or put another way, risk is equal to the probability of an event occurring times the severity of the event. So what does this mean? What is the probability that someone who walks by a decorative fountain in a highly trafficked area will inhale the mist from it? It's pretty high, right? What is the severity of the hazards to the passerbys if the fountain is contaminated with Legionella? Well, younger people with no immune problems may not get sick, or if they do, it may just be a cough or chest cold. In an older or immunocompromised person inhales Legionella or other harmful bacteria, the result could be hospitalization or death. This process is called risk characterization. Research has determined that there are various factors and activities that increase your risk of getting sick from building water systems. Many of these bullet points are straight from ASHRAE 188. Recirculating hot water systems, overnight stays, and the use of showers and residents with weakened immune systems. Then there are water processing activities that create increased risks, such as cooling towers, decorative water features, water softeners, and of course, any system that aerosolizes water. If you live in the facilities world, most of you are aware of the probabilities of exposure of most of these factors and process activities. We have discussed some of the safety aspects of managing your building water systems. Now let's turn to improving efficiency and reducing cost. We focus on operational changes that result in immediate cost savings without jeopardizing performance of your capital assets, not large capital projects that have 3-year or more ROIs. An independent evaluation of your expenditures on chemicals, services, and labor often turn up significant opportunities to reduce costs. So here are some specifics. Potable water opportunities. As the various uses and complexity of our water systems increase, the opportunities to optimize costs also increase. We will cover each of these in the following slides. Point of use filtration. Many facilities are using inline and point of use filters without data to back up the need, or they were put on during an emergent situation and no one knows when or how it is safe to remove them. Bottom line, they can become a hazard and expensive to maintain properly. Then there is supplemental disinfection. In other words, the on-site treatment of water with chemicals or devices. Many facility managers still believe that your municipal water supplier is responsible for the safety of the water in your buildings. They are not. They are responsible for delivering safe water to your distribution system or your buildings. After that, it belongs to you. Some facility owners are choosing to, or have been required to, disinfect their water after it crosses their property line for safety reasons. I am personally aware of a university that has installed supplemental disinfection systems on every one of their residence halls. Needless to say, this can be a complex decision that should be driven by data. Unfortunately, we see far too many cases where a company with a vested interest in selling the equipment or the chemicals was allowed to present the case for its purchase and installation. We have actually discovered many situations where we were able to recommend, based upon hard data, switching to a more preferred option or even the complete removal of supplemental disinfection, saving the facility tens, if not hundreds of thousands of dollars per year. Softened potable water. Here are some issues to take into consideration when considering the softening of your potable water. Softening can remove your disinfectant, thus creating a downstream safety issue. It adds sodium to your water, and it can cause corrosion if applied incorrectly. The key is to stay focused on the need and to implement only when necessary. Landscape water. The source and cost of your water drives much of the cost-saving opportunities with landscape water. The opportunities to save dollars comes from the watering requirements of the landscaping and the efficiency in delivering just the amount of water required to maintain it. The cost of your water will determine if there is an ROI associated with the capital investment required to switch to more drought-tolerant plants and grasses. Achieving an actual ROI may, of course, take a back seat to sustainability issues. The biggest portion of most large facility budgets goes towards the heating, cooling, treating, purchase, and disposal of water. It only makes sense that there would be significant opportunities to save costs in these areas. I will let you read these bullet points for yourself. These savings opportunities are not always present in many facilities, but there are very few facilities where we find zero savings. And in some cases, the savings discovered as a result of developing and operating a comprehensive water management program pay for the entire safety and efficiency program with dollars left over. Cycles of concentration, or in other words, how many times water flows around the cooling tower loop before it is dumped to waste. You want to optimize the use of water while taking into consideration the cost of water, sewer, chemicals, energy, and service hours, while ensuring that you are not jeopardizing the lifespan of the equipment. We see far too many systems where facilities are spending 2 to 3 times as much as they should be on cooling tower operations. Biocide strategy. There are many different water treatment strategies that will work. Does your water treatment supplier strategy optimize cost and performance? There is always a balance required between blowdown and chemical usage. I have an example for you in our next slide. So how much should it cost to treat cooling water? Between $1 and $1.50 per 1,000 gallons of makeup water for all chemicals, testing, equipment, and service. So for 12 million gallons of water, the water treatment expense should be $12,000 to $18,000 per year. This, of course, can vary from region to region, but it really is a reliable indicator. No matter your cost, if you are not tracking this number, you really don't know where you are. There are many questions you can ask your staff and water treatment supplier. Do you really need a proprietary oxidant, or will a non-proprietary product work just fine? How are you feeding them? Do you validate or measure their performance? Periodically running through these questions is a good management practice. Next, steam generation. Just like your cooling towers, you need to know how many cycles of concentration you are running in your boilers. It depends on several factors, but 50 cycles should be achievable without jeopardizing your capital equipment. Just like with the cooling tower checklist, there are many questions you can ask your staff and water treatment supplier. Do you monitor, track, and trend your water chemistry parameters? Have you looked closely at your injection points? How do you pre-treat your water? The answer to all of these questions can have a large impact on the cost optimization and performance of your boiler systems. So how much should it cost to treat a steam system? It should cost about $1 annually for every pound of steam per hour produced for all chemicals, testing, equipment, and service. So for a 10,000 pound per hour boiler, it should cost about $10,000 annually to treat the water. Again, this can vary from region to region, but if you're not tracking this number, you really don't know where you are. Here's an example of a very simple boiler with average costs running at 10 cycles of concentration, which is more typical than you would think. In most situations, you should be able to raise the cycles of concentrations to 50. Doing so results in savings of over $26,000 per year. Multiply that by several boilers or larger boilers, and pretty soon you are talking about some serious cost savings, all without jeopardizing your equipment. You have to have a strategy for the monitoring and control of your safety and efficiency processes. You can't monitor everything, and you don't want to monitor processes that have little to no impact on your program. If the program is not running as designed, you will never be able to figure out why you are not achieving your desired results. Verification is a quality assurance function. It is confirmation that the comprehensive water management program is running as intended. And you can prove it with data. And you can prove that when it gets out of whack, a highly technical facilities term, you take quick action to get it back on track. Remember, on the cost and efficiency side, you are looking for quantifiable savings of water, chemicals, energy, and most importantly, dollars, while preserving your capital assets. Here's another example. There are various ways to verify your program. You can check operator logs, flushing logs, and other records. A water management team set a target of maintaining 0.5 ppm of free chlorine at a distal location in their cold water system in order to maintain hazard control throughout the entire water system. The manpower required to take the readings was significant, so they installed a chlorine analyzer that took readings every couple of minutes. The chart you see is averaging the daily numbers. What they discovered was that they were only achieving a daily average of 0.2 ppm of free chlorine at the distal location. And they knew, because of their validation testing program, that this was not enough to control the biological hazards in their water systems. So they needed to remedy the situation. They initially had housekeeping trying to flush fixtures around the facility during their daily cleaning activities. The readings, not shown on this chart, were all over the place, and there was a concern they were flushing too much water. So they installed a water age monitoring device in conjunction with the chlorine analyzer that opened a valve to flush water, but only when the chlorine fell below the set point as measured by the chlorine analyzer. So they were able to raise their average daily free chlorine level to just above 0.5 parts per million. Flushing is controlling your free chlorine throughout the entire cold water system, and the analyzer is documenting the control. In this case, you are verifying that your program is being implemented as designed. The flushing device also measured the gallons of water flushed daily. As you can see, the amount of water flushed varies greatly from day to day based upon the other uses of water in the facility. This is a perfect example of how to balance safety with the efficient use of water. You flush only in the amount of water you need, no more, no less, to maintain the free chlorine at an appropriate level to keep the water safe. You have to have a strategy for confirming that what you are doing is actually working. It is the last step in the comprehensive water management program process, and it is how you determine if your water is actually safe or that you saved the dollars you thought you were going to save. Validation is a quality control function. Validation is confirmation that the comprehensive water management program is effective when implemented as designed and that you are reaching the goals you set out to achieve. But how often do you set goals in a program, but you never really know if you achieve them? On the cost saving and efficiency portion of the program, it is a reduction in usage of water, energy, and chemicals, along with commensurate reduction in dollars spent. The measures and metrics that come with regular validation will inform your operational decisions. And equally important, a well-designed program includes validation responses. What actions are you going to take if you are not achieving your goals? An effective, comprehensive water management program requires active oversight. So, if you are going to verify the program has been implemented as designed, and you're going to show or prove that it was effective, what do you need? You need documentation. We also like to mention the importance of third-party independence in the verification, validation, and documentation process. Think about defensibility. If you happen to end up in a situation where lawyers unfortunately get involved, who adds more credibility and expertise to your contention, because everything will be questioned, that your program was being run correctly by trained professionals with secure documentation to back it up? A comprehensive water management program is an insurance program for water safety and a roadmap to achieving real cost savings. Your insurance policy will not protect you if you do not keep good records. And if your roadmap flies out the window while you're driving, just like in the movies, you're not going to have the cost savings you thought you were going to have in your budget. So to wrap this all up, how do you operate a comprehensive water management program such that it achieves your safety, cost, and efficiency goals? It's simple. Follow the process. After you create your program, you should verify and validate it. Then reevaluate and adjust as necessary while documenting everything you do. Then do it again and again. This is not rocket science. The process works. Do be sure to thoroughly brief your plan to your senior leaders, including your plan to deal with validation test results. Remember, a positive test result for Legionella is not a cause to pull the fire alarm. But if you wait until you get a positive to brief them on your plan, your senior leaders will pull the fire alarm for you. Lastly, don't develop a plan you can't execute. Since ASHRAE 188 and other guidance is not prescriptive, you have some leeway to make a plan that fits your budget, if you adequately justify your decisions. Just follow the 7 steps to achieve a defensible, comprehensive water management program. Thank you for your time and have a good day.